Hey everyone, it's Mr. Wolf here. In this video, I'm going to be going over the setup for the PhET wave simulation app to help us answer the question, what factors affect the speed of a wave? All right. So a few things to set up is I'm actually going to switch this to oscillating instead of manual. And you'll notice some kind of just crazy things are happening here. So one thing I want to do is I want to make this a loose end. Kidding. No end, just so we can focus on the wave going out and not reflecting back. All right. Now, in reality, there's always this thing called damping, and that's just another word for friction, taking some of the energy out of the system of the string and into the atmosphere. And even though that actually happens for our purposes of simplifying things, let's just say there's no friction at all. So no energy is going to leave our system this entire time the wave's propagating across here through the string. Now, this is happening all pretty fast, and we're going to need to take some measurements on time, so it's going to be nice to slow everything down. So let's put this into slow motion right here. Okay, and then we'll set up our timer as well. All right, there are rulers, and you could use the rulers if you'd like. All right, but we don't have to have them necessarily. All right, and then you'll also notice that we could change things like the frequency of our wave. So here's a low frequency. All right, notice that this is just going up and down a lot slower compared if I raise my frequency and it goes all the way up here. Notice also I could change the tension of my string. All right, you can't really see the tension here, but we can imagine that that string is being pulled tighter, whether I bring it low or high or what have you. So I'm going to put my default setting here in the middle. Same thing with frequency. Let's make our default setting somewhere around 1.5. All right, and then the amplitude, I could adjust that too. It's how high or low my wave goes up and down. So here's a low amplitude, right? And then I could raise my amplitude, and that goes up much higher. All right. So in this simulation, we're just going to be manipulating either amplitude. I'm just going to set this to, I think it was at 0.75 or somewhere around here. Anyways, we're going to be adjusting the amplitude, we're going to be adjusting the frequency, and we're going to be adjusting the tension to see if that affects the speed of a wave. And how we're going to measure the speed of a wave is, notice how this is going up and down, up and down. Once it gets to the top, it's making a wave, and I'm going to follow that wave. Notice how my cursor's on that wave. I'm going to measure how much time it takes for it to get to right here, the beginning of my window. All right, and I'm going to do that with the timer. So let's see here. And make sure it's in slow motion, by the way. So the green dot's going up and down, down, up, down. I'm going to record on the next up, up, record. I'm following this wave right here. Notice that my timer is going. And once that wave hits the edge of the window, pause. So I get 1.72 for my time. Now that time is really measuring the speed because it's the same distance every time, right? It's like running the 40-yard dash. I don't need to know exactly how many miles per hour I'm going. I could just measure the time it takes to travel that far. And the smaller the time, the faster you're going. The larger the time, the slower you're going. So hopefully this video kind of helps you give a setup of how to run the experiments. Good luck.